example number 4. In our example number 4, no, automatically from the graph or from the drawing shown, you can already notice that the surface is not horizontal, but rather inclined. So we have here now, the problem is the motor winds in the cable with constant acceleration. Okay, from that one, you already have an idea that this one has a constant acceleration. Therefore, the constant acceleration kinematic equation can be applied in this one if we are asked if we can apply it, such that the 20-kilogram crate moves a distance s is equal to 6 meters in 3 seconds, starting from rest. Determine the tension developed in the cable. The coefficient of kinetic friction between the crate and the plane is mu k is equal to 0.3. Okay, let's write the given items. We have the mass of the crate is equal to how much? We have 20 kilograms. Now, do we need to determine the weight of the crate? Yes, because we have here the coefficient of kinetic friction. Therefore, frictional force is acting on the motion of this object of the crate. So ato na siya magamit sa ato ang acceleration. So the mass of the object is, or the weight of the object is just the mass times the gravitational acceleration. That is, again, 20 kilograms times 9.81 meters per second squared. We have a weight of the object equal to 196.20 or 196.2 newtons. What else is given? We have constant acceleration, and then so we have here that starting from rest. So at s is equal to 0, the time is also is equal to 0, and then the velocity is starting from rest. And then after 3 seconds, so at time is equal to 3 seconds, the distance s is already equal to 6 meters. Okay, so here, this problem we were not asked to find the velocity, but rather we were asked to find the tension. What is the tension? So anong na tension? Because we have a cable here. We have a cable pulling this straight on that direction along the s-axis. So since in this problem, no, it was using the s for displacement. Then let's say this is the s-axis. So on this side, no, there is a cable, and then there is a tension force pulling this one. Let's denote that by our symbol T. Next, determine the tension developed in the cable. Okay, that's it. That's it. So first, you just draw the FBD for this problem. Now, what are we gonna do with this one? Naka-incline man siya. It is already inclined. Should we draw the FBD of the incline or the with respect to the horizontal? So what we are gonna do with this one is that we consider na lang this one, no? That is for easier solving this axis. Let's say this is our x prime and y prime. This is our x prime and y prime. Okay, so you have a tension along x prime or along s. So our acceleration now is towards that direction. So in this one, that is towards the direction. So don't be confused, no, because naka-incline ni siya, ato lang na siyang murag plus star dire. So that we have a tension here. And then we have a normal force, always perpendicular to the surface. We have a frictional force, because we have a coefficient kinematic uh, friction, kinetic friction rather. That is F is equal to mu k times the normal force. How about the weight? So the weight is always perpendicular, always vertical or perpendicular to the horizontal surface. Now, what is the angle with this one? That is 30 degrees. So if we put the weight on our FBD, yan yung itsura, it looks like this. This is the weight, which is equal to 196.2 Newton, 30 degrees. Now, is it important to some forces along Y? Yes, because we have a frictional force, and then we need the normal force to get our frictional force, and then we can get our tension. Okay, so the summation of forces along Y prime is equal to mass times the acceleration along Y prime. Now, if you look at the Y prime axis, there is no acceleration because the acceleration is moving along the X prime axis. Automatically, this is zero. And then we will have the normal force minus the weight, 196.2 Newton cosine 30 degrees is equal to zero. And then we can obtain our normal force from this one. Our normal force is 169.914 Newton. Okay, let's try to solve for our frictional force. That is just equal to 0.3 times the normal force. That is equal to 50.9742. 50.9742 newtons. The next, what are we gonna do? Now we can try to solve the summation of forces along the x prime. And then we have the mass times the acceleration along the x prime. So forces along x, we have the tension minus the frictional force minus the weight, x component of the weight, x prime component of the weight, 196.2 sine 30 is equal to 20 kilograms times the acceleration. So you have the t minus 50.9742 minus 196.2 sine 30 is equal to 20 times acceleration. Our tension is equal to 20 times A plus 149.0742. Now, so ano na ito napag-consider? How are we gonna get A, the acceleration? So we can get the A or the acceleration, since this is a constant kinematic equation, constant acceleration, then we can use the constant kinematic equations. So unsa man atong pwede ma-apply, we have the initial position, final position, we have the time, we are short or unknown of our acceleration, we don't know the acceleration. We also have our initial velocity. So we can use S is equal to the final position is equal to the initial position plus the initial velocity times time plus 1/2 times the acceleration t squared. Final position 6, initial 0 plus the initial velocity that is 0 times time plus 1/2 a times time again 3 squared. So from this one we can obtain that our acceleration is equal to 1.333 meters per second squared. We already have the acceleration. We substitute that in this equation. Then finally, we can obtain our tensional force or our tension, which is equal to 175.741 Newton. And then this will be the tension developed in the cable by pulling the 20 kilogram crate.